After we saw in the colorectal cancer data that meat and fish together were related or good predictors of colorectal cancer, let's consider adding an additional predictor. Predictor that is categorical. So again, we could go into fit model. I already know that I have meat and fish as useful predictors, and so let's add in olive oil consumption as high-low and press run. And now we can see that we have accounted for even more variance in a significant model here, with all three predictors being statistically significant. And now how do we interpret olive oil low? Well, we don't just say that those eating low amounts of olive oil have higher estimates compared to those that are eating high olive oil, because that's not how the math works in categorical variables. You need to go over here and look at the least squares means. So when you are interpreting categorical variables as predictors, ignore the parameter estimates. All you need to keep is the p-value and say that olive oil consumption is statistically significantly related to colorectal cancer rates in the presence of meat and fish consumption, such that the mean colorectal cancer rate for those with high olive oil consumption is 22.3, and for those with low olive oil consumption is 27.7. This is about a 5% difference per capita in the colorectal cancer rate for high olive oil consumption diets compared to low olive oil consumption diets. So again, meat and fish stayed statistically significant in about the same manners. Meat increased a little bit, fish increased, and now we have olive oil consumption here. And so we have a better predictor model here of 65% of the variance being accounted for with three predictors. Certainly play around with the additional prediction of this multiple regression here for colorectal cancer rate, and you can see how some of the significance changes or does not in the presence of other variables. Always remember the same steps. The first step is to investigate your data. The second step is to fit your bivariate regressions so that you understand the relationships of your individual variables. The third step is to fit your model. And remember, the hypothesis is this model useful? This p-value tells you that. If the model is useful, report the statistics associated with it, report the parameter estimates or the effect sizes for each of your individual variables. For the continuous variables, interpret unit change. So for every 1 unit increase in fish, colorectal cancer goes up by 9.197. This goes up by 0.251. You could also do for every 10 units of meat and make this 10 times 0.25, or every 10 units of fish, 10 times 1.97. And then for the olive oil consumption, you want to report the least squares means. Graphs, figures, and tables become very useful in multiple linear regression. And as you practice more with regression, you'll learn which tables and which figures are most useful to you. Keep in mind that most of the figures produced by JUMP are statistical figures, and you will need to produce a figure for yourself and for your readers that makes more sense and tells your story.